Hi everyone. Today we'll be discussing the Leetcode problem of the day 966 Vowel Spellchecker. So in this problem, we are given a dictionary of strings. So this dictionary represents all the words with the correct spellings, and we are given a few queries. So in each query, we have to basically correct the word as per the dictionary. So suppose if you see the example, the dictionary has yellow, and in the query we have yellow, but in this the y and o are in the capital letters. So this type is also in this we have to convert this into the lowercase, and then it will be the correct will be the yellow from the dictionary. Another example is in the word list we have yellow, so we can convert this y to capital Y, and then it becomes the word equal to the dictionary word, and the word is yellow. And another example is the yellow all in lowercase, so this exactly matches what's in the dictionary, so that's what we return, correct answer. And we also have one more category that any vowel can be replaced, and once we replace a vowel, if it is contained in the dictionary, then we will return that word. For example, in this word list we have yellow with O capital, but in the query we have YOLLOW. So what we do is we convert this Y to capital, and since it's a vowel O, we convert it to E, and then this second O we make it capital. After doing this, it will be exactly equal to the word in the dictionary. So this is the correct word we written. In the second example, we have the query as YEELLOW. So here, like no matter what changes you do, it won't match in the dictionary, because the length doesn't match here. Here the length is 7. Here we have length is 6. And similarly in the third example also, no matter what you do, you can't get the correct word in the dictionary. So it's a no match. In that case, you have to return empty string. Also, we have priority rules. So the first priority is when you're given a query, if it exactly matches in the dictionary, you will return that word exactly as it is. After that, you will check for the only capitalization case. So if you are given a word and you just change the letters from capital or small, and you get the correct word from the dictionary, you will return that. So after that, if you have had to also change the vowels, then that is the third priority. So this is what the priority we have to return, we have to check. And if no matter what you do, no matter you change the capital or small letters, or you change the vowels, you won't get any of the word in the dictionary, then you just return an empty string. So let's see it through an example. So this is the dictionary we have, and the first word is kite. Here we can see that kite is exactly present in the dictionary. So for this we will return, let me just type it. For this we will exactly return kite. So for the second example, we have KITES. So for this word, if we change this I to E, and then this E to O, and make this S as capital, we can reach this word. Also for this word, if we just make K capital and T capital, we can form this word as well. And again, if we just make the K capital, we can make this word. And also for the same word, if we make K capital and we make this I as E, then we can also form this. We should also make this E as I. So for this word, we can see that 4 words from the dictionary are matching. But we can see that we have a priority order. So in the first is we have to check if the word exactly matches in the dictionary. So kites exactly doesn't match in the dictionary. So next what we check is only capitalization. So out of these all four words, only these two words are formed only by changing the capital letters. So out of these two also, we have to return the word that appears first in the dictionary. So for this, the answer will be this one. So let's see the third example. In this, we can make A equal to E, and then this E make it O, and make the S as capital. We can form this word. And we can also form the second word by making K capital, making changing A to I, T capital. We can form this. The third word, we can make K capital, A to I, and remain rest is same. So we can form this word. We cannot form the fourth word because the length is 5, so we can't make it a 4 length word. We can also make the fifth word by making K as capital, A as E, and E as I. So in this case also we have 4 choices. So again we see this priority. So first priority is if the word is exactly present. So this Kates is exactly not present here. So we go to the next category, that we only change the capital letters to form this word. So in all of these 4 words, we had to change any one of the vowel, so it doesn't fall into this category as well. So we go to the third category, that we can also change a vowel. So we have 4 choices, and again if we have multiple choices, we just return the first word. So for this case, the answer will be the first word. And finally, for the fourth word, we have this exactly in this. So we directly return this last word, because as per the priority, first we check if the word exactly is present in this or not. Now coming to the approach, what we can do is we will again follow the same order. So first we'll check if the word is exactly present in the dictionary or not. For that, we can simply use a hash set to just directly check if my current word is present or not. So what I'll do is I'll take a hash set and I'll just put all these original words in this. So whenever I have my word, I'll just check if it's in my hash set. If it's there, I'll directly put the answer as the word itself. Now let's move on to the next order, which is the changing only capital letters. So for this, what I'll do is I will create a hash map. In the hash map, what happens is I'll convert all these words into lowercase. So this KETOS will become KETOS in all small, and this kites will become kites in all small, and this also all small. Fourth one, it's already in lowercase, and the fifth one is KTIS. So if we can see that we have multiple words with the same lower string. So when we have that, we have as we saw, we have to return the first occurrence of the word in this. So this lowercase kites can be formed by making this and this as lowercase words. So since we have to return the first one of it, so in the hash map we will have for ketos, since it's only the occurrence is only one time, its value will be this string KTOS. And for this kites, its value will be this word KITES. We won't store this word because we have to return the first occurrence of the word. And also for this one, it will remain same, kite only. And for this KTIS, its value in the hash map will be, sorry, this one. So basically, if I just want to form this hash map, it will kind of look like this. Ketos is the key and the value will be this ketos. And the next key will be kites, and the value will be the first occurrence of that word. And the third key would be kite, and the value is again the same thing. And the fourth key is KTIS, and its value will be this one. So this is a hash map formed just by changing the letters from uppercase or to uppercase to lowercase. We also have a third condition where we can also change the vowels to any vowel we want. So what we do is, once we change all of these to lowercase, we will replace each of the vowel to a star. So this will become like something like this. All the vowels, I'll just replace it by star. Yeah, so all the vowels are replaced by star, and again I'll use one more hash map to store these values. The key will be the word converted with stars, and the value will be the first occurrence of which that word is formed. So if I have to create a hash map for this as well, for the first key we have the value as this KTOS. For the second key, again you can notice that this key has two values. The same key is formed by converting the vowels to stars from both of this, but we have to return the word which appears first. So that's why for this key this value is stored. And then the third key is this one, and the value will be kite. And the last key is this, and this is the value. So once we compute both of these hash maps and also a hash set, what we do is first we check the current word is in the hash set or not. If it's there, we directly return it. Otherwise, we will convert it to lowercase and then check if it's there in the lowercase hash map or not. If it's not present in this as well, we will convert the word. In the word, we will make all the vowels as stars and then check it in the vowel hash map. If it's present here, then we'll return this value. If it's not present in any of these things, then we will just return an empty string. Yeah, so here we don't if we don't have the word in this word list, no matter what we do, then we just return the empty string. So now let's move on to the code. So initially I'll just create a hash set which will store the exact word list as it is. It's original. In the hash set, we can directly fill the values from this string using arrays.asList. Also, I'll be creating two hash maps, one for the upper case insensitive and other for the vowel change. Hash map. Case mismatch. And the same thing for the vowel mismatch. Now what I'll also create a string array which will contain the final output, because in this we are given a string queries of strings, and for each of the string we have to return the correct word from the dictionary. The string length will be equal to the query's length. Now we all you have to do is first generate the values in both of the hash maps. So for that, I'll just iterate on the words list. Now once we get the word, first I'll just convert the word into lowercase. Dot to lowercase. Now all I have to do is first check if this lower key is present in the case mismatch hash map. If it's not present, add it. If it's present, just ignore it, because we only want the first occurrence of the word. So if case mismatch dot contains key lower, if it doesn't contain, we'll just add it. Dot put lower, and the key is lower, the value will be the original string. And similarly, I will do it for the vowel. But for the vowel, first we have to convert the vowel into all the stars. So in the string, we have to convert each of the vowels into stars. So for that, I'll just create a function equal to vowel star, and I'll just pass the lower string. So once we iterate the string, we just have to check if the string dot caret is a vowel, we add a star. If it's not a vowel, we just add the original character. Caret I. For this also, it's better to just create a function is vowel str dot. If it's a vowel, then string builder dot append a star. If it's not a vowel, then string builder dot append the original character itself. And at the end, just return the string builder converted it to a string. sp dot to string. Also, let me just fill in the isVowel function. Return C equal to A or C equal to E or C equal to I O C equal to U. We are only checking the lowercase letters because before we converted the string into lowercase, so all the uppercase letters will be converted to lowercase, so we just need to check the lowercase vowels. So yeah, now we have the vowel and we just have to pass check for the string and put it in the hash map. Now once all the hash map is done, we'll now iterate on the queries to just fill in the values. I'll just copy this loop. Queries.length. So now again, we will go based on the priority order. So first we'll check if the original hash set original dot contains queries of I. If the original if the query of I is already present, we just set the result of I as that. Result of I is queries of I. Now we will move on to the case mismatched hash map. Else if case mismatch dot contains key query of I. When we should not directly check query of I because in the case insensitive hash map we first converted all of the keys into lowercase. So this queries of I key as well, we have to convert it into lowercase. If it is present, then result of I will be the value of this case insensitive case mismatched dot get lower. Now finally we will check the case where we just change the vowel and we get the string. So similarly, else if, and also now we have converted it into lowercase, but we also have to convert the lowercase into stars. So we can again use the previous function. So vowel hash vowel star, and in this you just pass the lowercase string. So if this is contained in the hash map, we can just directly put the value in the result of I equal to case. Now it's not case mismatch, we will have vowel mismatch. We should check in the other hash map. I think one more. Yeah. So after all these checks, if in neither of these cases we have the string, so we will directly set result of I equal to empty string, and at the end return result. Let me test. Word list. Okay, L is in lowercase. Yeah, and submit. And now coming to the time and space complexity. So For space complexity, we have created a hash set and two hash maps, and the size of the hash maps will be just the size of the word length, which is 7, and they will contain the strings, and strings can be up to length 5000. So space complexity will be order of n into the length of string. And then the time complexity will be initially we are just pre-processing and creating the hash maps. So for that, first we're iterating on the word's length, so that will be order of n, and for each of the word length we are iterating on the word, we are converting it into all the stars and all, so that will be length of string. So this is for the pre-processing, and after that we are just running the queries, and in the query we are just doing constant operation, not constant operation, in here as well we are converting the words into lowercase and also into vowel, so this will contribute to the order of the string length. So this will be order of query into length of str. So that overall time complexity, we can just say it's something like this: order of length of str into n plus q, where n is the size of the word list and q is the size of the query list. And also I've also written this code in Python. If anyone wants to view this, I'll also add this in the description as well. Hope it helps.